This lesson teaches you how to create both a frequency distribution and a stem and leaf plot. So let's start with the frequency distribution. Notice that the data that we're going to be using is over on the left. These are the 20 scores that you just saw in the picture's worth 1,000 words. Notice that there are 5 headings: class interval, frequency, percent, cumulative frequency, and cumulative percent. I've created class interval size 5 for this frequency distribution, so the highest one, which I like all the higher scores at the top, is 95 to 99, and the lowest is from 50 to 54. So let's fill out these columns and talk about how you do that. The frequency column is simply a way of you annotating how many scores or how many observations are within each of the class intervals. So there was 1 score within the 50 to 54, 2 scores within 65 to 69, 3 scores within 80 to 84. The percent column is found by actually identifying the percentage of scores within each of the class intervals. It's found by dividing the frequency in each interval divided by the total n. So in this case, it's 20 scores. So 5% of the scores were from 50 to 54, and again we found that by dividing 1 divided by 20. 10% of the scores were 65 to 69. That was calculated by 2 divided by 20. And jump on up. In the 80 to 84 column, our class interval, 15% of the scores were found there, 3 divided by 20. Now let's talk about the cumulative percent and cumulative frequency column. The thing that you need to realize is as we work our way up the columns, each of those columns we are accounting for more and more of the scores. So when you get to the top of the cumulative frequency column, you should see the number of scores, total number of scores, which is 20 here. And when you get to the top of the cumulative percent column, you have accounted for 100% of the scores. So always can kind of check yourself or check your math by knowing that fact. So how do you fill those columns out? To fill out the cumulative frequency column, the first thing you're going to do is bring over the 1% of the score, or the one observation in the 50 to 54 column, and then you're going to add that 1 to the frequency in the column or the class interval above it, and bring that over. So 1 plus 0 is equal to 1, and then you keep working your way up. That 1 plus the number of observations, 60 to 64, so 1 plus 1 is equal to 2, and we'll do one more. 2 plus the number of observations in the class interval above it, so 2 plus 2 is equal to 4. All right, and you can go ahead and work your way up, check my math, make sure that's done correctly. Now let's talk about the cumulative percent column. Same thing is true. Bring the 5 over. So 5% of the scores are in that lowest class interval. 5 plus the percent in the class interval above it is 5 plus 0 is equal to 5. That 5 plus the 5% in the class interval above it, so 5 plus 5 is 10. And then 10 plus the percent of scores in the class interval above it, 10 plus 10 is 20. And again, you can work your way all the way up that column until you reach the top, and it should indicate that you have accounted for all of the scores. So again, that top number should be 100 or 100%. The cumulative percent column is used to identify the position of the score in the distribution. So for this data, a raw score of 66 is in the class interval at the 20th percentile. So you need to start linking these, the numbers in this column, to percentiles. What that means is that 20% of the scores were 65 to 69 or below. I'll say that again. The way that you interpret a percentile is that, in this case, 20% of the scores were 65 to 69 or below. So percentiles indicate the percent of observations that fall at or below a specified value. In this case, we're using class intervals. So 20% of the scores were 65 to 69 or below. we'll be talking quite a bit about percentiles as we move through the semester. So hang on for more about that. Another thing I want to talk really quickly about are quartiles. Quartiles are points in the distribution of scores that divide the distribution into 4 equal parts. And so the famous ones, or the ones that we're going to identify, are the 25th percentile, 50th percentile, and 75th percentile. So the 25th percentile will be somewhere right in here. The 50th percentile will be someone right in there. And in this case, we actually know the 75th percentile is within the class interval 80 to 84. So again, we'll be looking at a lot of this, or all of this, a lot more, and you'll be doing a homework problem where you actually create a frequency distribution. At the bottom of this page are 2 stem and leaf plots for you. Class interval size 5 on the left, class interval size 10 on the right. The stem for each of these is the leftmost digit, and the leaf is the rightmost digit. So our highest score in the distribution was a 96. So it is the only one in that upper class interval. There were 2 92s, so there's 2 2s in that class interval. And so one thing that you do need to recognize is that every data point, all 20 of those scores, should have a place within this stem and leaf. We're going to jump down and notice that there's nothing in the 55 to 59 class interval, but you don't put a 0 there, because if you put a 0 there, that would indicate that someone scored a 50. So if there's not a score represented in a class interval, you simply leave it blank. One of the nice things about stem and leaf plots is you can quickly tell lots of information about it. So what's the most frequently occurring score here? Looks like it's probably a 76, because there's 3 6s right there. Which class interval had the most observation? Again, it would be the 75 to 79, because there's more leaves in that class interval than in any other one. Let's jump over and look at the stem and leaf class interval size 10. Again, the leaf is the leftmost digit. The stem is the leftmost digit. The leaf is the rightmost digit. And again, every score in the set of data gets a place in the stem and leaf. So again, which class interval had the greatest number of scores? It would be the one in the middle from 70 to 79.